All right, let's dive right in. We're going to unpack one of the most basic but also most important ideas in all of technology. How on earth does a computer, which is really just a machine that thinks in on and off switches, learn to remember something from the real world, like your name? Let's figure it out.
Yeah, really, think about it. At their core, computers are just super fast calculators that only speak the language of ones and zeros. So how do we possibly get from that simple binary world to our complex one with names and ages and all sorts of ideas? That's the big puzzle we're going to solve today.
Okay, so first things first, computers need to remember. Before a computer can do anything useful for us, it has to have a way to just hold onto a piece of information. And the simplest, best way to imagine this is with our first big idea, the labeled box. In the programming world, we call this labeled box a variable. It's nothing more than a name we give to a little chunk of the computer's memory. It's our way of saying, hey, computer, see this spot right here? I'm labeling it user age. I'm going to put a number in there, and I need you to remember it for me.
But you can't just start using these boxes willy-nilly. In a language like Java, you have to tell the computer you need one before you can use it. You have to declare it. So this little line of code here is doing exactly that. It's telling the computer, hey, I need a box that can hold a whole number, an integer. Please label it A for me, and while you're at it, go ahead and stick the number 30 inside. You're reserving your box ahead of time.
So, okay, we've got these boxes. But that immediately brings up the next logical question, right? Can we just put anything we want in any box, or do we need different kinds of boxes for different kinds of stuff? And in Java, the answer is a big, resounding yes. You need different boxes. It's what we call a strong typed language. All that means is that every single box, every variable, is designed for one and only one specific type of data. Once you say a box is for numbers, you can't just try and sneak a word into it later. It won't fit. Java actually gives us a whole toolkit of different boxes. You know, for your simple whole numbers, you've got types like int or long. For your more complicated numbers, the ones with decimal points, you've got types like double or float. It really is all about picking the right box for the data you have. And here's a really crucial detail. These boxes also come in different sizes. A byte, for example, is teeny-tiny. It can only hold a number between -128 and +127. An int, on the other hand, is much, much bigger. And which one you choose really, really matters. So, what do you think happens when you try to stuff too much information into one of these little boxes? Let's find out. Let's do a little experiment. We'll grab one of those tiny byte variables. We know its maximum value is 127. So we'll put exactly 127 in it. And then we're going to push our luck. We're going to try to add just one more. We are pushing this little box right to its breaking point. So what's your guess? What happens? You might think the computer will complain, or maybe it just stays at 127. But what actually happens is much, much weirder. So what is in that box right now? Get this, it's -128. The number wraps all the way around to the absolute lowest value the box can hold. The best analogy is an old car's odometer flipping from all nines back to all zeros. This phenomenon is called integer overflow, and it's a perfect, if slightly scary, example of why knowing the size of your data box is so incredibly important. Okay, part 3, putting your data to work. Because let's be honest, just storing data in boxes is fine, but it's not that useful yet. The real power, the magic, happens when we start to make these boxes interact with each other, when we start doing things with the data that's inside. And we do this using what are called expressions. An expression is basically just a recipe. It's a set of instructions that takes values, either raw numbers or values from our variable boxes, and combines them using operators like plus or minus or multiply. The whole thing gets crunched down into a single new value, which we can then, you guessed it, store in another box. This, of course, leads to another interesting challenge. What happens when our recipe, our expression, starts mixing different types of data? What happens if you try to pour the data from a big box that's happy with decimals into a little box that only wants whole numbers? Let's set up a quick example. We'll create one of those double variables, our box that's designed specifically for decimal numbers, and we'll just store the value 3.6 in there.
So far, everything is fine and dandy. All right, now for the fun part. We're going to take that 3.6 and try to jam it into an int box, a box which, remember, absolutely hates decimal points. Now, you can't do this by accident. You have to explicitly tell Java, look, I know this seems wrong, but just do it. Force it in there. And that act of forcing one type into another is called casting.
So let's think this through. The value we have is 3.6. We're forcing it into a box that can only hold whole numbers. So what's going to happen? Does it round up to 4? Does it round down to 3? What do you think the value of x is going to be?
The answer is 3. And this is so important to understand. Casting does not round. It truncates. It's like it just takes a pair of scissors and brutally chops off anything and everything after the decimal point. Poof, it's gone. This is what's known as a loss of precision, and it is a classic gotcha for anyone learning to code. Okay, we've talked about variables, our labeled boxes. We've covered types, expressions, and even casting. So now let's put the whole shebang together and see how these simple concepts combine to create something that's actually useful. Let's look at a real tiny program.
So we're going to break down a simple temperature converter. First thing we need is a place to hold our starting temperature, right? So step 1, we declare an int variable, our box for whole numbers, we label it Celsius, and we put the number 28 inside. Okay, step 2. Now it's time for our recipe, our expression. The computer takes the value out of the Celsius box, multiplies it by 9, divides it by 5, then adds 32. The final answer from that whole calculation gets stored in a brand new int box that we've called Fahrenheit. And finally, step 3. I mean, what's the point of doing the math if we can't see the answer? This last line of code just tells the computer, hey, whatever number is currently sitting inside that Fahrenheit box, just print it out on the screen for me. Simple, elegant, and it just works. And there you have it. That's the whole process right there in front of you. We combine these simple ideas, variables, types, and expressions to make a computer perform a useful, real-world task. This is the absolute fundamental building block of pretty much any program you can think of. So we've mastered storing a single number. That's a huge step. But let's be real, the world is way more complex than that. Think about something like a social media profile. That's not just one number. It's got a name, which is text, an age, which is a number, and a list of friends, which is a whole other collection of information. So how on earth would you build a box big and complex enough to hold all of that? Well, that's a fantastic question for another explainer. Thanks for joining me.